Hi, today we'll discuss about calculating the number of particles in cubic unit cell. In this, we are going to study about first simple or primitive unit cell. Simple or primitive unit cell. Okay. In this, first you see, we have taken the cube. If you see the cube, we are getting the 8 corners. 1, 2, 3, 4, 5, 6, 7, 8. Having 8 corners. Okay. It has 8 corners of particles or atom. So each atom is shared by 8 cubes. 8 cubes. Contributed each corners of atom or particles. 8 into 1 by 8 equals 1 atom in simple or primitive unit cell. Yeah. Now we are going to study about second unit cell. That is second unit cell. It is body centered unit cell. The name of it in the body. In the cube, we are taking that body. You see, already we know that in SSC or simple cubic unit cell or primitive unit cell, the contribution of 8 corner particles is 8 into 1 by 8 equals 1 particles. Similarly, in body centered, again we using the body. In the cube, it's having the body. It's one body. The contribution of one body centered particles is means it's contributing only one. Okay, body. It's 1 into 1, therefore 1. The total number of particles per BCC unit cell is, first we are taking that corners and next we are taking that body. Is 1 into 1. 1 by 8 into 8, it gets a 1. 1 into 1, 1. Total then 2. The 2 number of particles present in body centered cubic unit cell. Next, we are going to study about phase. Phase. In this phase, see, phase centered cubic unit cell. Similarly, here also the contribution of 8 corner particles is 8 and 1 by 8 is nothing but the one atom is shared by the surrounding 8 cubes. Okay. Similarly, the phases for this plane, it is a phase. For this plane, it will be the phase. For this, it will be the phase. For this plane, it's having the phase. For this, you will have the other phase. See, total we are having the 6 phases in a cube. The contribution of 6 phase centered particles, we know that it's having 6 into each particles half of it shared in the plane, in another half does not shade. For that we are taking off. Do you understand? The 6 phases means you take a ball in a plane. You take a ball. If you keep means half of only will be situated. For example, you take this ball. If you keep means half will be occupy the plane. In half will be does not occupy. For that only we are taking of 6 phases. Half will be the occupy the cube. Okay. Similarly, we are going to talk here 6 into half. Therefore, 1 plus 3 will get 4. In phase centered cubic unit cell, the number of particles present is 4. Okay. Next topic, we are going to study about relation between radius of atom and edge length. Relation between radius of atom and edge length. In this, first we are going to study about SSC. SSC is nothing but simple center cubic. Simple center cubic. We are going to write the cube. In this cube, we are naming the plane, that is A, B, C, D, E, F, G, H. If you take a plane, first we are going to take a plane that is ABCD. ABCD plane. A, B, C, D. In this plane, the atoms are occupied. Okay, this we are taking that it is the radius of the atom. It is the radius of the atom, a single atom. What we are taking? The single atom that is occupied the space corner of the A. Okay. Now you see the edge length. If you talk the edge length of the cube, it is the edge length. All sides the edge length. Okay. Now we are going to study about the edge length. Edge length is nothing but A. Edge length is nothing but A equals the radius of atom. Means if you taking a plane, the A is equals to the edge length. A is equals to 2R. Correct? No? 2R. It is the edge length of simple center cubic is A is equals to 2R. If you want to find out the radius of the atom, R equals A by 2. It is the radius of the atom in simple center cubic. Next we are going to study about face center cubic. That is called FCC. Similarly, we are writing that cube telling that face center cubic means we are taking any face A, B, C, D, E, F, G, H. We are taking any face means we can take I can take this as a face. Okay, means I'm taking the plane that E, F, B, A. This is the, I'm taking the face, correct? No? The atom here can write it is the radius, no? Radius of the atom, and this is the face. We are getting the two radius here in the face. Okay, we know that the edge length is A. Edge length is A means it is A. Similarly, this also be the A. According to Pythagoras theorem, we are applying in triangle AEB. We want to find out EB. No, EB is equals to EA square plus AB square. We know that EA is nothing but A, means A square. AB. AB is similar to CD. Therefore, its length is A. We can write 2A square. 2A square. EB is nothing but EB. EB is nothing but how many radius are there? 1, 2, 3, 4. We can write 4R. We can write 4R means we want to write 4R square. 4R square. If you apply the square on right hand side, root 2A. If you want to find out the radius of the atom, R is equals to root 2A by 4. If you want to find out A is nothing but 4R by root 2. Root 2 means A value, edge length of face center cube is 4R by root 2. If you want to find out the radius of the atom in face center cube is nothing but R is equals to root 2 A divided by 4. Okay. Last, that is BCC, body center cube. Body center cube. A, B, C, D, E, F, G, H. I am taking a body. Body is nothing but center. Center means it is the atom. It is atom. It is also atom. If you write the radius R is R. Correct? No? We know that edge length of AE is A square. A we know this also edge length. A is edge length is A. Correct? No? We can write that straightly. 3A square is equals to 4R. 3A is equals to 4R. How can we get the 4R? Because we are getting 4 radius in the body center cubic. We can, okay, till 3A square, we are getting the edge length. Edge length is 3A square. If you want to find out, means edge length, R. If you want to find A is equals to root 4 by 3R. It is the edge length of body center cubic. If you want to find out the radius of the atom, R is equals to 3A by root 4. It is the radius of the atom in body center cubic. Yeah. Now going to study about the chart, that is crystal system and number of particles and relation between edge length and radius of the atom. Edge length and radius of the atom. First we are going to study about SSC. SSC, number of particles are 1. What is the edge length? Edge length is nothing but A is equals to 2R. What is the radius of the atom? R is equals to A by 2. It is, when come to FCC. FCC is nothing but face center cubic. The number of particles are 4. Here, what is the edge length? A is equals to 4R by root 2. root 2. Then what is the radius? R is equals to root 2a by 4. It is the radius. Next, last we are going to study about BCC, body center cubic. The crystal system name, number of particles are 2. What is the edge length? Edge length is equals to A is equals to 4R by root 3. What is the radius? R is equals to root 3 by 4A. Root 3 by